Hello everyone, welcome to my YouTube channel. In this video I'm going to be discussing the section B of the NEET 2022 abroad paper. Let me start off with the physics section B, 36th question. That is the first question of the section B. It says that three capacitors each of capacitance 0.3 microfarad are connected in parallel. This combination is connected with another capacitor of 0.0 microfarad in series. Then the equivalent capacitance of the combination is. Since three capacitors are in parallel, we know for parallel combinations the capacitance gets added like resistors in series. So therefore the equivalent capacitance of the three capacitors in parallel will be 0.9 microfarad in series with another 0.1 microfarad is just like a resistors in parallel, that is C1 C2 by C1 plus C2, that is 0.9 into 0.1 by 0.9 plus 0.1, which comes out to be 0.09 microfarad. So the answer for the 36th question is option number 2. Moving on to the 37th question. The 37th question, a string of length L is fixed at both ends and is vibrating the second harmonic. The amplitude at antinode is 2 mm. The amplitude of a particle at a distance L by 8. The first step in this question is to identify the nodes and the antinodes. This is a transverse wave problem. If you have no sonometer type problem, is that type of a problem. This is a transverse wave. So the position at the fixed end is the node. This one is the antinode, which has the maximum amplitude. Node, not pressure amplitude. Pressure amplitude is maximum at the node. This is antinode, where the displacement amplitude is maximum, and this is the node again. The distance between the node and antinode is lambda by 4, and distance between node and node is lambda by 2. Since there are three nodes, the distance between the first node and the third node will be lambda. So lambda is equal to the length of the string. And in the 37th question, they are asking the amplitude of particular distance L by 8, which means the amplitude at distance of lambda by 8. How to find the amplitude at lambda by 8? See, we know for a stationary wave, the amplitude varies at different positions. That is, it varies with position. That is, x coordinate it varies with. So it's a sine function or a cos function. How do you know whether it's sine or cos? Here, if you see cos kx, let's say when x is like maximum, we know k is equal to 2 pi by lambda. That is, k, which is angular wave number, is equal to 2 pi by lambda. When x is equal to 0, then kx will be 0. Then sin kx should be 0. That means when x is equal to 0, sin 0 will come out to be 0, means amplitude must be 0. So it must be at the position of the fixed end. So that means this equation satisfies that of a sine curve. So we should use the equation amplitude is equal to amplitude A0, that is the maximum amplitude, sin kx, and k is equal to 2 pi by lambda. X here, the position at which they want us to find the amplitude in this question is equal to lambda by 8, because lambda is equal to L here. So I just substitute sin kx, which is sin 2 pi by lambda, into lambda by 8, which is sin pi by 4. Sin pi by 4 is what? 1 by root 2. 1 by root 2 into maximum amplitude, that is 2 millimeter. 1 by root 2 into 2 millimeter comes out to be root 2 millimeter as the final answer. The answer for the 37th question is option number 3. Moving on to the 38th question. 38th question, the concept is based on rectifiers, full wave bridge rectifier, but if you see the output voltage here comes out to be that of an half wave rectifier. Why? Because in the case of a full wave rectifier, when the switch was open, we will get an output in both the directions. That is, the output curve for a normal full wave rectifier will look like this. That means we get the output where in whichever way we get the give the positive negative sign. But here, since I have inserted another diode 5 when the switch is closed, The diode 5 will be in forward bias in one situation, and in the other situation it will be in reverse bias. The situation when it will be reverse bias, then the diode in the full wave rectifier will not have, the resistor in the full wave rectifier will not have a output voltage. Therefore, in one situation it will have an output voltage, another situation it will not. Why? Because I have inserted a diode 5. So answer for 30th question is option number 1. Moving on to the 39th question. 39th question is direct assertion reasoning based question. Gauss law for magnetism says the magnetic flux through any closed surface is 0. This is absolutely right. Why? Because no magnetic monopoles do not exist like that of free electric charges. So the integral, this is one of Maxwell's equation, integral of B dot dA over a closed loop is equal to 0. This is Gauss law for magnetism. Magnetic monopoles do not exist. North and south poles, yes, they occur in pairs, allowing vanishing net through the surface. Yes, it's absolutely right. Because magnetic monopoles do not exist, that's why the magnetic flux through a closed surface is 0. So the assertion and reason is true, and it's the correct explanation. Now, many people might be thinking we have something called pole strength. Why is that, sir? To make the definition of magnetic moment easier and to solve it like that we did for electric charges. Like magnetic moment is pole strength into distance between the poles. Just to make the question easier, done that. It's a theoretical concept. It does not exist in reality. Pole strength. An AC source given by V is equal to, that is EMF is equal to EM sin omega t, is connected to a pure inductor L circuit. And IM is the peak of the AC current. The instantaneous power is applied to the inductors. Remember the mnemonic Iceman, Eli the Iceman. That is the mnemonic given in Resnick Halliday book. Eli the Iceman means EMF leads current in the case of an inductor, and current leads EMF in the case of a capacitor. So EMF leads the current in the case of an inductor by pi by 2. So the current equation will be I is equal to Im sin omega t minus pi by 2. But we cannot simplify this further. So what would I do? I would take the minus sign outside, and it is Im sin of minus pi by 2 minus omega t. Sine of minus x is equal to minus sine x, because sine is an odd function. Im minus sine of pi by 2 minus omega t. Now we can do it using simple trigonometry. Sine pi by 2 minus omega t is cos omega t. So this comes out to be minus Im cos omega t. No, we know instantaneous power is equal to Vi. That is, V is given as Vm sin omega t into Im cos omega t minus Im cos omega t. I have taken the minus in front. And we know sin omega t cos omega t can be simplified as sin 2 omega t by 2. How? By multiplying and dividing by 2. 2 sin omega t cos omega t sin 2 omega t, and there's a 2 down. So the answer will come out to be option number 2 for the 40th question. Now moving on to the 41st question. The fraction of the original number of radioactive atoms that disintegrates during the average lifetime of substance. The average lifetime of substance is the time in which the original number of radioactive atoms, it becomes the activity, or the radioactive atoms, it becomes like the initial number divided by E, which is the exponent. So n will become n0 by n0 will become n0 by E. Initially, let's say the number of radioactive atoms was n0, then finally will be n0 by E. So the number of atoms that have disintegrated are n0 into 1 minus 1 by E. So disintegrated is n0 into 1 minus E. Fraction disintegrated will be that which is divided by the original number of atoms that were present. That is, the fraction disintegrated is the number of atoms that have disintegrated by the number of atoms that were originally there. Number of atoms that were originally there is n0. Number of atoms disintegrated is n0 into 1 minus 1 by E. So fraction disintegrated is E minus 1 by E, which comes out to be option number 4. Now, moving on to the 42nd question. The figure shows the displacement and time xt graph of a particle moving along a straight line. The correct statement about the motion of the particle is the motion. Here you can see in the graph that up to time t0 the position coordinate of the particle keeps increasing regularly with time, that it is increasing at a constant pace. It's a straight line graph between x and t up to t0. That means the velocity is constant because dx by dt is equal to constant. But if you see after time t0 the x coordinate does not change, that means the particle is not moving, basically it's at rest. So 42 answer is option number 1. 43rd one. Air is pushed carefully in soap bubble of radius r to double its radius. If the surface tension of the soap solution is d, the work done in the process. Work done in the process is nothing but gain in surface energy if done very very slowly. But okay, if it is done slowly, we'll assume. So work done in the process is gain in surface energy. And we know surface energy is equal to change in surface energy is equal to tension into change in area. We know for a soap bubble it has two interfaces. What is the two interfaces? First we have air here, we have this is water, and we have air outside here. So we have air, water, air. So this is interface 1 and this is interface 2. As in the case of a drop, here it is fully water. And outside air, this is water. So only one interface we have here. Since there are two interfaces, that means there are two surfaces, and the surface area of a sphere is 4 pi r square. So t, and there are two interfaces, so I will multiply by 2 outside, and 4 pi into change in radius squared will give us the change in area. Change in radius square is, we are doubling the radius from r, so final radius become 4r square, and initial radius squared is nothing but r square. So this will be 4 pi into 3r square, which is 12 pi r square, and we have a 2 outside, so 24 pi r square t will be the answer. So the 43rd one answer comes out to be option 2. 44th one. The magnetic field of a circular loop at a very far point on the axial line varies with distance like that of a magnetic dipole. The magnetic field due to magnetic dipole varies inversely with the square of the distance from the center on the axial line. If you see, the statement 1 is absolutely correct, because if you see in the NCERT textbook in chapter of magnetism and matter, it says that the magnetic field of a very small circular loop, since it's far away, it's a very small, it can be assumed similar to that of a magnetic dipole. That's what they're doing here. But the second statement says that it varies inversely with the square of distance, it varies inversely with the cube of distance. So that's incorrect. So 44th one answer is option number 1. Now moving on to the 45th one. When a particle with charge plus q is thrown with an initial velocity v towards another stationary charge plus q, it's repelled back after reaching the stationary distance near this distance r from plus q. The closest distance that it can reach if it is thrown with an initial velocity 2v is. Now, in this question, let us try to visualize the situation. If the particle plus q is thrown with velocity v towards a stationary charge plus q, since they both are positive, they will repel each other, and since it's thrown at the velocity v, it will be decelerated. And there will be a point when its velocity comes to 0, and then after that it begins to get accelerated due to the repulsive force in the opposite direction, right? So when it becomes 0 velocity, the distance between the particle is maximum. We can also do it using differentiation. We can prove it using maxima minima concept. Now let us apply the principle of energy conservation. Why? Because electrostatic force is a conservative force, therefore we can apply energy conservation principles here. And the work done by conservative force can be taken as drop in potential energy. So initial potential energy is 0 plus initial kinetic energy is half mv square. Final kinetic energy is 0 plus final potential energy is KQQ by R. Now R is the nearest distance, so R comes out to be 2KQQ by mv square. We can see nearest distance is inversely proportional to the velocity squared. So if the velocity is doubled, then the nearest distance will reduce by 4 times. That will become R by 4. So the 45th answer is option number 1. Let's move on to 46th question. 46th question is a direct question of errors. The determination of the value of acceleration due to gravity by simple pendulum method employs the formula 4 pi square L by T square G. We know the relative error for delta G by G is delta L by L plus 2 delta T by T. Because we know, let's say a quantity X is equal to P power A, Q power B, R power C by, let's say, L power M. Then delta X by X, you learn this property, comes out to be A delta P by P plus B delta Q by Q. Errors always get added, plus C delta R by R plus M delta L by L. So this is the property of errors with exponents. Now the 46th question, the determination of the value of acceleration due to the gravity by simple pendulum method, we have already solved, and the answer comes out to be option number 1. 47th question, a monochromatic light of frequency 500 terahertz is incident on light slits of a Young's double slit experiment. The distance between the slits and the screen is placed at distance 1 meter, and the width of the 10 fringes will be. We know width of a fringe by Young's double slit experiment. This is a normal question. It does not invalidate any assumptions. That means it does not make any assumptions untrue. That means all the assumptions here are valid. So the fringe width is d lambda by d, which is there. D, capital D, is nothing but the distance between the slits and the screen, that is given as 1 meter, and lambda is nothing but the wavelength, which is the speed of light divided by the frequency, which comes out to be 6 into 10 power minus 7 meter, divided by d, which is the distance between the slits, which is given as 0.2 millimeter, which is 2 into 10 power minus 4 meter. This comes out to be 3 into 10 power minus 3 meter, which is 3 millimeter. And they're asking the width of 10 fringes will be 10 into 3, which is 30 millimeter. Now the diagram of this question, let me explain. The diagram of Young's double slit experiment is somewhat like this. This is the distance between the screen, which is 1 millimeter. This is the width. This is the distance between the slits. This is the width of the slits, which we do not need to know, but we know the width of the slits is directly proportional to the intensity passing through the slits. That means the light intensity passing the slit is directly proportional to the width of the slit. If the slit widths are equal, then the intensity passing through is equal. The distance between the slits is this, which is given as 0.2 millimeter, and the frequency of light lambda, which is coming from a single source, then only these two can be coherent. That means they do not have any phase difference. Moving on to the 48th question, the answer for the 47th is 30. So you have already illustrated. 48th question is based on balanced Wheatstone bridge, that is meter bridge instrument. In meter bridge experiment, the null point is at a distance of 30 cm from A. The resistance of 16 ohm is connected in parallel with resistance Y. The null point occurs at 50 cm from A. The value of resistance Y is. Now, how do we approach this question? We know this is a balanced Wheatstone bridge when the galvanometer shows null deflection. So first part is they're given the null deflection at 30 cm from A. That means this is 30 centimeter and this is 70 centimeter. We know this is directly proportional to resistance, the length here. So therefore we can directly do it using length rather than taking resistance per unit length. Okay, now by balanced Wheatstone bridge concept, x by 30 comes out to be equal to y by 70, right? So x by 3 is equal to y by 7, which means 7x is equal to 3y. Now the next part of the equation, they are given a resistance of 16 ohms connected in parallel. We know for parallel the R equivalent comes out to be R1 R2 by R1 plus R2. So it will be 16y by 16 plus y by 50. Since both are equal, then the resistances should be equal. The lengths are equal, so the resistances must be equal. So now what do we do here? We just substitute this in x, that is 7 into 16 y by 16 plus y is equal to 3y. Y will get cancelled. 7 into 16 is 112, which is 3 into 16 plus y, which is 48 plus 3y. 48 taken there comes out to be 64, which is equal to 3y. So y comes out to be equal to 64 by 3, which is the value we want in this question. Resistance of y. The 49th question. The temperature at which RMS speed of atoms in neon gas is equal to the RMS speed of hydrogen molecules at 15 degrees Celsius is. We know RMS speed is given as root 3 RT by molecular mass. Now, molecular mass, so therefore if their speeds must be equal, the temperature by molecular mass quantity should be equal, because R value is not going to change. It's this universal gas constant, and 3 value is same for both. So therefore T by M is equal to constant if both their values must be equal, that is RMS speeds must be equal. So temperature for hydrogen is given as 15 degrees Celsius, which is 288 Kelvin by a molecular mass of hydrogen, which is 2, and molecular mass of neon is given as 20.2, and the temperature of neon we need to find. This 2 and 20.1 can be cancelled as 10.1. 288 into 10.1 comes out to be 2.9 into 10 power 3 Kelvin, that is 2900 Kelvin. So 49th one answer is option 1. Moving on to the 50th question. Two planets are in a circular orbit of radius r and 4r about a star. At specific time, the two planets and the star is straight line. If the period of the closest planet is t, then the star and the planets will be again in straight line after minimum time. They will be in a minimum time when they come in this position again. When will they come in this position again? Let's find out. If you see this question, we do it using Kepler's third law. According to Kepler's third law, that is t square is proportional to r cube. That means for the first star, you can see that the time period, if it was t, for the second star, since it has radius of 4r, that is 4r from the second planet, or rather 5r from the first planet. If you see, it has a radius of 5r from the first planet. By Kepler's law of orbits, its time period should be, let's see, t square is proportional to r cube. T square is proportional to 125 r cube. So t1 by t2 is equal to 5 power 1 by 3. If you see the second planet's time period will be 5 power 1 by 3 times that of the first planet. I mean 125, not 125, yes, 125 power half. It will be 5 root 5 times that of the first planet. But rather we could do this question relative to the planets with each other. If you see relative to this planet, the distance of this planet is 4r. If you assume the other planet to be revolving around this planet, we can see that here its time period related to this planet will be coming out to be 8t. And the time period of this is t The time period of the first planet is T. So that means its omega must be 8 times of the other planet. That means when it completes 8 revolutions, this completes 1 revolution. So when will they come back in the same time? At time 8t, 16t, so on. And they ask after minimum time. So here the answer comes out to be 80. This is a little trickier question. Thank you. Hope you enjoyed the section B of physics abroad paper. I'll be coming up with more videos. Thank you. Please like, share and subscribe.